and check it. We'll see how is it calculating. So from S to A, it will calculate using that first link. I would rather suggest you to look at the paper also for the slide number 11, which is there, like PMF computation is explicitly mentioned in the paper. So in that it is clear, very clear how is it calculated. And then decision making. Okay, in decision making we again calculate the EPD, that is expected
Slide number?
packet delay. Slide number 12, the next slide. So 11, 12 and 11 to 11 to, okay, 11 through 14 slides are very important, because in that only it is showing how it is calculating PMF, decision making, and how the final result is obtained. And the other problem that we need to check is decision conflict. There might be decisions where it is calculating one or more links going to the same node. So in that, decision conflict resolution is very easy. Once we read that, it is very simple. When two or more nodes are trying to make the decision, suppose B is active for one particular time period. So when A and C wants to transmit it to B, so they'll look for that active time period and they'll start transmitting the data to C. To B. A and C will try to transmit the data to B. That time the conflict can occur, and whichever has to transmit first, that has to be decided. So in that way, what is the decision? What is the resolution? The resolution will be both of them will back up themselves, like they'll not start transmitting, and whichever has the best link quality among both of them in A and C, that will start first, and the other node will wait till A finishes the transmission, and after which B will see, okay, if A has completed the transmission, let me just check. If the transmission is completed by some other node, then B will not start transmitting. So it is avoiding that energy. It is avoiding that energy loss where it will transmit the redundant data again to C. So that's how decision resolution, conflict resolution is helpful for energy saving. And in 18th slide we'll have understanding so far. So in that you can get the grasp of all the 17 slides that you have read already, wherein it will mention what is the important part in the slide till now. Slide number 18, and then we have evaluation criteria. That is, I don't think he might ask anything from that, though we need to know like how is it better than other techniques. So in evaluation part, what we can look forward is to look at the graph, which is flooding performance with different duty cycles. That
Slide
is
number 21.
Slide number 21, exactly. From slide number 21 to 23, you can see where it is clearly mentioned like improved pure flooding. And then how is it better, opportunity flooding, and what is the best delay that can be obtained. So you can compare that graph and you can mention that in the exam if you ask like how is it better than other techniques. Okay, so there is one testbed performance also that they have done. I don't think you might ask anything from that. Alright, and conclusion will cover everything like what it is based on, why is it used, and what can be done. So this is basically you need to know from this paper, nothing much. So the basic thing is slide number 18, wherein we have understanding so far, and then the key idea that is in slide number 10, and then we need to know slide number 11 through 14.
Slide 14, could you please explain the example?
Well, this example,
Just short.
Right.
yeah, sure. In this, suppose this is based on the PMF computation again, wherein it will calculate PMF and then it will calculate the decision with expected packet delay. So basically what we need to know is he will not ask the calculative question in that. What he might ask is if expected packet delay is less than, he might give expected packet delay and DP. DP is probability delay. Okay, DP is quantile delay. In that he might give DP and EPD, and he might ask if which node to take. So whenever EPD is lesser, in slide number 13 we have if EPD is less than or equal to DP, then the packet is needed to as the probability of that node has already received. So whenever EPD is less than or equal to DP, that packet is marked as needed and it will be transmitted. But whenever EPD is greater than DP, it will not transmit. So the advantage is whenever it is needed, so we'll make sure that data transmission is happening. But if it is not needed, that means the data must have already been received. So the redundant transmission is avoided. So it is saving the energy that way. So that is the basic thing you might ask. Any more questions? And decision conflict resolution is very easy. I would suggest like once if you give a reading to it, it is quite okay. Like 3 or more nodes are trying to transmit to one node, then they back themselves. They wait for the best link quality.
Slide number.
Slide number 16, decision config resolution.
Next slide.
So they back up themselves, and whenever one transmission is happening, they'll wait, and whenever transmission is completed, they won't send. So that way redundant transmission is avoided. So this is the basic gist of whatever we have studied in this paper. Okay, thank you.
Yeah, very good. Good.
Monica?
Understood.
Yeah. तेरे बोर्ड से कौन से यूजर से